Hi, I'm Joe Mazzolotti, and this is how to add a SwiftUI screen to a Turbo Native app. We're going to cover the basics of SwiftUI, how to work with the path configuration to leave some business logic on our server. We're going to cover networking in iOS to make some native network requests, and we'll talk about some ideas for improvements. Let's dive in. We'll be building off of a example repo that I put together just for this project and that I'll be using for future blog posts. You can get it at github.com/Joe Mazzolotti/turbo native example. What this does is set us up for a really bare bones turbo native iOS and Rails app. You'll see here that on the server we have a very simple CRUD for articles, kind of like the classic blog post example. We can edit articles, delete them, add them, nothing out of the ordinary. The iOS app as well is pretty much everything inside of a single turbo navigation controller. Most of this is from all of my blog posts. It's about the bare minimum you can get by with Turbo Native. If I run this, you'll see that we have very similar to what our web view looks like, but all rendered on the iOS app. So no modals or anything fancy like that, but it does work. So let's dive in. The first thing we're going to do is make this show screen on an article a fully native screen. So the first thing that we'll do here is that we're going to create a new SwiftUI view. So we'll create a group over here on the left, call it view, because we will have more than one eventually. We'll then add a new file, and this time we'll use a SwiftUI view. This will give us a little bit of a scaffolding to create that SwiftUI view. Click next. We'll call it article view and click create. Already we get a little bit of bare bones scaffolding here. I'm going to pop open the preview and just show here how we already have something rendering in SwiftUI with zero code written on our own. What we want to do here is that an article has a title and a description. So we're going to create those kind of hard-coded for now, and we'll just kind of write out Turbo Native tabs. We'll give this a font of title, and then we'll also have text of the, this row of buttons, blah, 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 and we'll wrap this in a vertical stack so it renders up and down across the screen. We'll make sure to align this to the left, give it a leading alignment, so we actually scooch everything over a little bit. And then we're also going to throw a spacer at the bottom to push everything up to the top. Now we're still kind of centered, and that's because the background of this, if we throw a background color of something like orange on this, you'll see that it doesn't fill the full width of the screen. We can kind of cheat that by throwing this spacer here in an H stack, and also then throwing this text in an H stack here, and throwing a spacer at the end of it, which will fill the width of our screen, and then this spacer down here will fill the height. So now that we have kind of an idea of how this will look, we'll throw a little bit of padding on it, so it just kind of gives us a little bit of room to breathe. And we want to actually pull this data from somewhere. And in SwiftUI, that usually means we'll want to do a view model. So back in our Project Explorer, we'll create a new group. We'll call it view models. Little trick here, I always like to right click and do sort by type to get these all kind of alphabetized if they're all folders, but it does work pretty well when you have different types of files in there. New view model here, there's no template for it, so we'll just create a new Swift file. We'll call it the article view model. And here we're going to start with combine. I call it combine. This is kind of like the glue between how stuff passes around in SwiftUI. You won't see it used explicitly very much because SwiftUI has a lot of bindings built in, but we are going to be using an observable object which comes directly from combine, so this is a great place to import it. We'll have a class called the article view model, which will inherit from that observed object. Observable. What this means is that we can add published properties. So if we do like a published var title, this is actually going, whenever time this title changes, anything that's listening, that's observing to this view model, will automatically apply those changes to it and re-render the view if needed. So here we'll set that to Turbo Native tabs. We'll do the same thing with a body, and we'll just grab this row of buttons, blah, blah, blah. So we now have these like kind of dynamic set statically properties. And back in our article view, we want to inject our view model into it. So we'll have a observed object here called our view model. I like this pattern a lot because you don't have to know the name of the view model, it's just view model. And it'll be of type article view model. If I try to build, we fail because down here in our preview, we're not passing in that view model. So that's pretty quick. We can just pass in an instance of our article view model here, Command B to build, we're back to succeeding again. Now that we have that wired up, let's actually add the text to the screen. So in this title, we'll grab the title from the view model, and in here, we'll grab the view model and the body. If I render that preview again, we should get the exact same thing. Not very exciting. But here's where it starts to get interesting. If I throw a task modifier off of that vertical stack, and I tell the view model that the title is something new, you'll see that when we render the preview, that something new changes. So we didn't actually have to change it in our view or tell our view to do anything. It just knows that when this observed published property changes, to re-render the minimum part of the view that's necessary. Cool. So we now have that. How do we actually render this on the screen? So for that, we're going to want to go close out both of these and pop back in our Turbo Navigation controller and check out our private visit function. This gets called anytime we click a link, and it's us telling Turbo Native essentially what we want to do with that URL that was just visited. So normally we could do something like, if proposal.url.path, not path, but like path components dot first equals articles, and the second one equals 1 or 2 or 3. It gets really both verbose. We could use a regex, but we don't really want that to exist in our iOS app. What if we end up changing the route of articles to blogs or posts? We have to deploy a whole new version of our iOS app just to make that change. It's not very, maintainable. So we can introduce the concept of a path configuration. A path configuration moves that logic to our server. So to set one up on our session where we create our lazy session here that manages all of our Turbo native instances and all that good stuff, we can grab a session and give it a path configuration. We'll create a new one, give it a sources option, and it passes in an array. And we can say, hey, grab this from our server. Hit this URL when the app launches, pull it down and configure our app. We already have a root URL kind of globally defined up here, so we can grab that and then do a pending path and give it a configuration.json. That will essentially say visit localhost 3000 / configuration.json on launch and pull down that data. So here we have our server logs. I'm going to clear that out. I'm going to run the app, and you'll see in just a second how we immediately get a request to configuration.json. Obviously, we don't have that yet, so we get a 404. This is what happens when we actually load, the screen. But right away, Turbo Native kicks that request off for us. It will cache it. It will do all sorts of nice things. So let's do it. In our routes file, we're going to create a new resource called configuration. And we only need the show method here so we can kind of keep that lean. And then we're going to create under app controllers configurations controller, RB. Configurations controller inherits from application controller, and we have a show method which just renders JSON. It renders a hash of JSON. 2 keys are required, settings and rules. Settings is like this arbitrary hash of arguments that we can remotely configure certain things in our app. We're not going to touch on that today. But rules are an array of hashes that essentially say when this URL path matches, apply these properties. So what we're going to do here is grab a patterns and apply properties. The patterns that we want to match are all of the articles show screens, right? So what that comes out to in regex is the beginning of the string with our hat, match articles with the slash, and then we're going to match any number, so 0 to 9. We're going to match any number, more than one, or one or more, so more than 0, and then match the end of the string. So this will match things like, articles 1, it'll match articles 500, but it won't match articles, which is what we want. We don't want to match the index view. We'll apply something here. This is arbitrary to us, to our app. I like to use the concept of controller and give it an article show. We can do something like article view or article index. Article is probably fine for this. If we have more, we'll want to make that a little bit more specific. So when we run this now, I'm going to run the Turbo Native app. I'm going to watch our server logs real quick. This does not 404 it 200. So when we hit our configuration.json, that is exactly what we want. What I'm going to do here is set a breakpoint when we do our visit. So right away, when we start to visit our index page, we can print out our proposal. Our proposal has a lot of stuff going on. It has the URL, it has options, and it has properties. Properties are what we're interested in. Let's scroll up so we can see where we are. So if I do proposal.properties on this root URL, we get no elements, an empty hash for our localhost 3000. That makes sense. We didn't configure anything for it. But when I click Turbo Native tabs here, clear this out. So now our URL is /articles/2. If I print out our properties, we now have a hash. It has 2 elements. The first element is the key. The second element is the value, controller, article. That's exactly what we want. That's how we can now start configuring what or which paths to route and then do specific stuff on our client with that. So let's hide this from here, Command-Shift-Y to hide that, stop, Command dot or Command period. And here we're going to say if proposal.properties, we're going to grab the controller key, cast it as a string, equals article, we're going to want to do something. Otherwise, we are just going to do our normal Turbo Native visiting. So here, if I run this, when I click on if everything worked, if I click on one of these, nothing will happen. We're essentially getting into this block on line 35. Nothing happens on line 35. Here's where we want to actually create or render our view. So we're going to render a SwiftUI view. So the first thing we want to do is import SwiftUI. I like to sort these, so QRSTU. And then down here, we're going to want to use something called UI hosting controller. This is a UI view controller that manages a SwiftUI view hierarchy. It's a perfect bridge between a UIKit app, which is what we have, into SwiftUI views, exactly what we have. So we'll create our view model, which is our article view model. We'll create our view, inject our view model into it, and then we'll create our controller, which is our our UI hosting controller, and give it this root view of the view. We now have a UIKit UI view controller subclass to work with, so we can just push that onto the stack like any other screen would in UIKit. Run that again with Command R. When I click one of these, we get our rendered SwiftUI view on the screen, looking good. Except it's the exact same data every time. Remember, we hard-coded this data into the view model. So we need a way to dynamically grab that from our server. And to grab that from our server, we need to have a JSON endpoint. So back in Vim, we are going to open up our views. We're going to look at the articles view, and we're going to create a show.json.jbuilder view here. This is what's going to get rendered when we hit like /article/2.json, etc. And here, I don't use JBuilder that often, so I'm actually going to just kind of copy paste a little bit here, but we have json.title will be the article.title, json.body is the article.body body, and then we also need to know what, actually that's it. We only need to know those two things. So we go to our server, we visit an article, and we slap on .json, and you'll see that we get the title and the body. If we go to articles/1, we get the title and the body. So now like we've built our own API, right? With just one file right here, we've built our whole API for grabbing this. So how do we actually fetch that in our view model? We need to add a new function. So I'm going to call it fetch article here, and it's going to be an async function. If you're familiar with how JavaScript works, it's pretty similar. It tells everything going on here that this function does not return immediately, it returns later. So if you want to call it, you have to be in an asynchronous context and you have to wait for that response. So we want to fetch that URL, right? We want to essentially say URL equals what? Look, we can grab our local host 3000 article slash. We don't know what article we're visiting yet, right? So instead, we're going to inject that into us. We're going to grab an instance of URL and create that as a private property here. We need to import foundation to work with our URL because that's not part of the Swift standard library. Try an equal sign. So now we're going to inject that URL so we can actually go fetch it, but we're failing because our view preview needs a URL. So I'm just going to give it an example URL, and that'll just be like a quick thing right here. We're not actually using this, but we need to appease the compiler. Example.com, because otherwise this won't build because it's strongly typed. We have to pass something in. And then finally, where it actually matters in our visit function, we need to pass the URL. And here we can just grab it directly from the proposal. We already know that we're routing it the right way. We're going to assume that the page that we tried to visit via Turbo Native is the right URL to hit with our JSON API. And we can modify that by taking our URL and appending a path extension for JSON. Now, whatever we have, we just slap on .json, and we can use appending to return essentially a new URL, URL2, whatever. So we have our URL. We now need to actually fetch it. To fetch it, I like to use a URL session. We can grab the shared session, and we can do a data from URL. So we'll just kind of copy this down here. So we now have a way to fetch our data, right? This can throw, it can raise errors, and it also is asynchronous. So we're going to throw this whole thing in a do catch block. And here we're just going to, if something happens, we're just going to print out the error. We failed to fetch article. Error.localized description. Error, where did error come from? We automatically get error as a let error here. We just don't have to write it. But this is a data and request tuple, and we do try await because it can throw, and it is asynchronous. That's where our await comes in. We don't actually need request, we only need data, so we're just going to use an underscore to tell the compiler that, hey, don't worry about that. But with our data, it's a data object. It's not a string anymore. It's like data with a capital D, right? Like option click on this, we'll see the type, capital D, data. And the best way to transform data into serialized objects is to use a JSON decoder. A JSON decoder takes data and turns it into a struct. So we can define a struct called article, make sure that it can be decodable, essentially changed from JSON data into Swift stuff. And it's going to have a title, and it's going to have a body. Now we can say JSON decoder decode article class from data. And now we have we have an article instance here. If this fails, we'll just catch the error right here and print it out to our log. So all of that, both of these tries are kind of getting thrown into the same catch. Great for demo, not great for a production app. But the best part about this is that we can just do self.title equals article.title and self.body equals article.body. These self.title and self.bodies are the published properties from above. So now when we run this thing, we're going to be able to click Swift for Ruby developers, and nothing happens still. We're still not rendering the screen. If I set a breakpoint here, you'll notice that this method is never actually getting called. We haven't told anyone to call fetchArticle. Back in our view, we can use that same task modifier to await for our view model to fetch our article. Now, as soon as the view loads, like you saw before when we did the preview, it's going to kick off a background task that will fetch our article on our view model. Let's remove that breakpoint. Let's run this one more time. And you'll see that when I clicked Swift for Ruby developers, we get our data populated exactly as we want. But we do get a bunch of purple. All this purple is essentially saying you updated the UI from a background thread, so you should like bounce back to the main thread. That is probably, it's usually over my head. Honestly, my first approach is to just throw a main actor on this thing, and that usually solves the problem. And for here, it does, so I'm happy with that. Main actor essentially says when you return from doing anything asynchronous, do it on the main thread. That is a big paraphrase. I'd recommend reading up on it to know the details, but for this and for this demo, it works perfectly. So there you have it. That is how to use SwiftUI in your Turbo Native app. There are a bunch of ways that we can improve this. This error handling could be rendered onto the screen. We can have like an error variable up here and then switch on that in our view. We probably want to pull this code out into its own view controller, maybe like an article view controller or an article show, something like that, so we can kind of contain this SwiftUI logic and view model wrangling into one. And we also have no way right now to go anywhere else after this screen. So if we wanted to add like an edit button or a delete button, we don't have any way wired up. So those are really good ideas to if you wanted to improve on this and take your skills to the next level with Turbo Native. I recommend trying to do each one of those. As for the source code to this, you can find it on my GitHub. Again, I'm Joe Mazzalotti. I write about Turbo Native every week on my weekly newsletter, which you can find at mazzalotti.com. I'd love to have you join it, and when you do, you get an invitation to our private Discord group where we chat about Turbo Native, Ruby on Rails, and what it's like to be a solopreneur. Until next time, thanks.